Hello, everyone. Today we are discussing descriptive data analysis techniques. We all know that it is one of the important parts of data analysis, so we will mainly discuss why it is used and its core components. Descriptive analysis, descriptive statistics, summarizes and presents raw data so you can understand its main features quickly without making predictions or testing hypotheses. It's usually the first step in any data analysis because it tells you what the data looks like and whether further inferential analysis is appropriate. The main purposes of descriptive analysis are: it summarizes large data sets into simple numbers and visuals. It describes central tendency, typical value, and variation, how spread out values are. It detects errors, outliers, missing data, and distribution shape, skewness. It communicates results clearly in tables and charts for reports or theses. Key summary measures. 1. Central tendency. It answers the question, what is the middle or most typical value in the data? Central tendency refers to a statistical measure that identifies a single value which represents the center or typical value of a dataset. It helps to understand where most of the data points lie. It is used to summarize large data into one representative number. It includes mean. Mean is the sum of all values divided by the number of values. Median. Median is the middle value when data is arranged in ascending or descending order. Mode. Mode is the most frequent value in the dataset. Central tendency helps summarize and understand data. Use mean when values are regular and balanced. Use median when there are extreme values. Use mode when dealing with categories or most frequent behavior. 2. Dispersion. It refers to the degree of variation or spread in a dataset. It shows how far the data values lie from the center, mean or median. Even if two datasets have the same mean, their spread may be different. So dispersion helps to understand the consistency, risk, and reliability of data. In simple words, how scattered or spread out the data values are. Range. Range is the difference between the highest and lowest values in the dataset. Variance, sample variance. Variance measures the average of squared deviations from the mean. It shows how far each value differs from the mean. Standard deviation, sample standard deviation. Standard deviation is the square root of variance and is expressed in the same unit as the original data, making it easier to interpret. Interquartile range, IQR. IQR measures the spread of the middle 50% of the data. It is based on quartiles. Dispersion helps to understand how consistent data values are. Small dispersion, values are close, more consistent. Large dispersion, values are highly scattered, less consistent. 3. Shape and other measures. Besides central tendency and dispersion, data also needs to be described by its shape. Shape tells us how data values are distributed around the center. Skewness, asymmetry of distribution. Skewness measures how symmetric or asymmetric the distribution of data is. Skewness equals 0, symmetric distribution, e.g., normal distribution. Positive skewness, right skewed, long tail on right side, mean greater than median, e.g., income levels. Negative skewness, left skewed, long tail on left side, mean less than median. Skewness helps in choosing correct statistical methods, mean versus median. Kurtosis, tailedness or peakness. Kurtosis measures how heavy or light the tails of a distribution are compared to a normal distribution. 3 types. Mesokurtic, normal curve. Kurtosis approximately 3. leptokurtic, heavy tails, sharp peak, kurtosis greater than 3, more outliers. Platykurtic, light tails, flat curve, kurtosis less than 3, fewer outliers. It helps identify the presence of outliers and riskiness of data. Percentiles and quartiles, position measures. These measures tell where a particular value stands in the dataset. Percentiles, P. Divide data into 100 equal parts. Example, P50 equals 50th percentile equals median. P90 equals 90% of data values are below this point. Useful in entrance exams ranking, cutoff scores in competitive tests. 4. Minimum value. Minimum value is the smallest number in a data set. It shows the lower limits of the data. 5. Maximum value. Maximum value is the largest number in a data set. It shows the upper limit of the data. Common visualizations in descriptive analysis. 1. Histogram. A histogram shows the distribution of continuous, numeric data. Data is divided into intervals, bins, and bars show how many values fall in each interval. Useful for identifying shape of distribution, normal, skewed, detecting outliers or gaps in data, checking spread and concentration of values. 2. Boxplot, box and whisker plot. A boxplot displays the median, quartiles, IQR, and outliers in one chart. Shows median, central value, box, IQR, middle 50% of data, whiskers, data range, dots, outliers. Useful for comparing multiple groups, example, male versus female scores, detecting skewness and extreme values. 3. Bar chart. Bar charts show counts or percentages of categories using rectangular bars. Used for categorical variables such as gender, male, female, education level, bachelor, master, Likert scale responses, agree, neutral, disagree. Useful for identifying most common category, comparing frequency between groups. 4. Frequency table. A frequency table lists each category or value and shows frequency, number of times it occurs, percentage, proportion of total. Useful for summarizing survey responses, understanding category distribution, preparing data for charts. 5. Scatterplot. A scatterplot shows the relationship between two numeric variables by plotting points on an XY graph. Useful for identifying correlation, positive, negative, no relation, detecting patterns, clusters, and outliers. Examples, height versus weight, study hours versus exam marks.